Alright, so remember that yesterday we started talking about our trig functions of our general angles, and then we reminded ourselves about some of our special angles. And remember that our goal with all of this is to create basically what we're calling our unit circle, which is going to be a one-stop shop that gives us all of our special angles in degrees and radians. It's also going to give us our sines and cosines of all of those angles as well. So, remember that yesterday we talked about that sine is y over r and cosine is x over r. Yes? Okay. Now, just for reference, what did we say that we're going to let our r be on our unit circle? It is the hypotenuse, but what did we say we're going to let it be? 1. So if r is 1, for each of our points, what does sine end up being?
Y.
Just y. And what does cosine end up being?
X.
Just x. So when we're on our unit circle, it's really nice because we can always just look at a point and know that my cosine is my x value and my sine is my y value. So that's why we like our unit circle, because it gives us a lot of information really, really quickly. Does that kind of make sense? Yeah? Okay. And you can kind of think about it, it goes in alphabetical order. So cosine comes first and then sine. Yes? Because a lot of people, I don't know why, because you're used to saying like sine, cosine, you want the sine to be the x, but it's the opposite. Your cosine is your x value, your sine is your y value. Alright? Then, the last thing that we needed to talk about are our reference angles. So, a reference angle is going to be the acute. So what does acute mean? Smaller than 90. Created by the terminal side of an angle and the x-axis. Which, if we recall, when we drew our triangles yesterday, those were the angles that we were using in our triangle, right? It's the angle that's kind of inside of that triangle. We should call them our reference angles. So, let's look at what I mean here. So, if I'm in my first quadrant, yes, that's what my angle would look like. So, this would be our theta. We're going to label our reference angle as theta prime. So, where would our reference angle be located? Well, it has to be the terminal side and the x-axis, so it can't be that part. It can't be the rest of it because that wouldn't be acute, right? So, is this already to my x-axis? Is it already an acute angle? Yeah, so my theta here equals my theta prime. So when you're in your first quadrant, your reference angle is just whatever angle you already have. Now, it's a little bit different when we're in our other quadrants. So when I'm in my second quadrant, this would be my theta. where would our theta prime be located? What's left of this little piece would be our theta prime. And if we recall, when I drew my triangle yesterday, that's the angle that we ended up using. Yes, we shouldn't call it a reference angle, but it is our reference angle. Yes? So then, looking at something that would be in our third quadrant, that would be theta. So then where would theta prime be? It would be what? Agreed. So it's going to be basically this part right here. We okay with that? Because again, it has to go to our x-axis. So that's why we went up instead of over. And it has to be a cube. So that's why we went to the negative x-axis instead of the positive x-axis. So what is our last option? When it's in the fourth quadrant, that would be theta. So what would be our theta prime? The rest of it? So like the mouth of our Pac-Man shape? So that would be theta prime? Well, okay with that? So how would I find those theta primes algebraically? Fancy word. Not quite. So in my first one, what is theta prime equal? Just theta. So we don't have to do anything fancy. It's nice. If they give you 30 degrees, your theta prime is also 30 degrees. If they give you pi over 4, your theta prime is also pi over 4. However, in my second quadrant, it's not quite as simple. If I know what theta is, how would I find what theta prime is? We don't want to minus 180. Subtract it from 180. We want the positive angle, so it would be 180 degrees minus theta. There were too many people talking at the same time. I didn't quite hear. So what is our other option though? What if we're not in degrees? Agreed. We would just change it into a pi instead. Yes? Now, in my third quadrant, what would we do? So I'm wanting to know what this leftover piece is, right? This time we do subtract 180. Because now my theta is bigger than 180. So we subtract off basically that top half of a semicircle, and we would be left with just what our theta prime is. But again, if we're in radians, what would we be subtracting? Pi. So far, so good? Yeah? Okay. So then, lastly, if I'm in my fourth quadrant, what would we do? So the whole rotation is 360 degrees. The part that I have left over is what we're needing. So if we just subtract pi, we'll get that. So if I'm in radians, what is 360 this time? 2 pi. So we would do 2 pi minus theta. Yes? No? Maybe? Well, okay with that? Question so far? No? Okay, so let's use those formulas a bit. So it says finding reference angles. So it asks us to find the reference reference angle theta prime for each of the following. So for A, what might it be helpful to do? What's always helpful for us to do though? Draw a picture. Because it's going to help us figure out which quadrant it's in, which tells us what thing we want to do, right? So where is 300 degrees? So how do I know that it's not in my third? Yeah, so remember that my negative y-axis is 270, and we know that this is larger than 270, so that's where our angle would be. So what did we say we want to do then? Subtract it from 360. We don't want to subtract 360 because that would give us a negative angle. And again, an acute angle has to be between 0 and 90, so it does have to be positive. So what do we get? 60 degrees. Okay with that? Alright, what about part B? What quadrant are we in this then? How do I know? Without looking at the unit circle, how would we know? Okay, so, yeah, so 180 is pi, right? Which is one whole. Is 2/3 bigger than a whole or smaller than a whole? Smaller. Okay, and then remember in our first quadrant, my numerators have to be 1. Okay, does that make sense? So if it was like 5/3, would it be able to be in my second quadrant? No, because that's bigger than a whole. Does that make sense? So it's kind of your starting spot is, okay, is this fraction smaller or bigger than one whole? And then you know it either has to be in my top 2 or my bottom 2. And you can kind of go from there. So yes, this one will be in our second quadrant. So what do we do to find our theta prime? Agreed. So I want to do pi minus 2 pi over 3. Now, some of our instinct might be to switch 2 pi over 3 to degrees and then try and do it in degrees. But what did we say we want to get better at? Not doing that. We want to get better at doing operations with radians. Does that make sense? So even if it takes a little bit longer now, in the long run, it's going to get us better at it, which makes problems shorter in the future. Okay? So, how would I subtract these?
You said 2/3 taken from a whole.
Yes. So we can either find the common denominator, which yes, will end up with pi over 3. So we have a third left. Now, what's different about part C? It's negative. So, what direction are we rotating? Clockwise, yes? So, if I were to rotate into my first quadrant going negative, what is this bottom angle then? Almost. Negative 90, right? So this would be negative 90, okay? Which means that going all the way to the opposite negative x-axis would be what? Negative 180. So, from here, how many quadrants am I going to be in? We're going to be in 2 quadrants. But remember that we still label our quadrants going the opposite direction. So what quadrant would we really be in? The third. We'd be somewhere over here. We're all okay with that. Alright. So what do we need to do first? Do any of our formulas deal with negative angles? No. So what might it be helpful to do? Yeah, the picture. Is there a way for us out there to make negative angles positive? Yeah, Yeah, so remember we talked about coterminal angles, okay? So remember that my starting and my stopping spot for a coterminal angle would be the same. Hang on. And it would give us the positive version of that. And so then we would be able to use our formulas. Does that make sense? Alright, so how do we find a coterminal angle? So in this case, what do we want to do? Add 360, and what do we get? 225 degrees. So then, from there, we can't find our reference angle. What would we do? 225 minus 180 equals 45. Would there have been a shortcut?
Just like subtracted 135 and
Not negative 180, but 180. So so me adding 360 and then subtracting 180 is the same thing as just adding 180. So if you did it that way, that's fine. If you can kind of see, oh, if I add a half rotation, it will get me what I need. But otherwise, you can always just find the coterminal first and then find your reference. Yes? Are we okay with that? Alright. Now, the reason that we like coterminal angles, or we want to use coterminal angles. So, if I'm in my quadrant, and we have ourselves some angle in my third quadrant. Okay? So this is theta. Can I create a right triangle with my full theta? Using the entire thing? No. Where would we have to draw our triangle to? Up to here, right? What angle is this right here? Oh, yeah, but in general, what would I label that? It's an acute angle. We went to our x-axis, so what angle is that for my theta? It's my reference angle. So this is my theta prime. Agreed? Yes? Okay. But also notice, if this is theta prime, where does theta prime live? What type of angle is theta prime? An acute angle. So we could draw the same triangle, right? With that there. Agreed? And just because my triangle's like flipped, are all of my sides still going to be the same length? Yes. And so what ends up happening is, as long as we know our sines and cosines and tangents of the things that live in our first quadrant, we can use our reference angles to find any of our other quadrants. Does that make sense? So it's kind of similar, remember when we just added 90 or added 180 to all of our first quadrant stuff? We didn't really need to memorize the rest of them. We could find them just by doing those operations. Same thing here. Our reference angles allow us to just have to memorize the stuff in our first quadrant, and then we can always find the stuff in the rest. You all with me? So, if I want to use the reference angle when I'm given something that's not an acute angle, what do we have to do first? If I want to use the reference angle, we have to use our formulas to find the reference angle, right? So when I'm looking at 4 pi over 3, what would my reference angle there be? Or how do I find it? What quadrant are we in? The third. So what would we do? Not subtract pi, but oh no, sorry, yes, you're right. So subtract our pi, yes. Okay, and so what do we get? Pi over 3. What do we notice about the numerator of our original and the numerator of tells us is that my cosine of 4 pi over 3 would have the same triangle as my cosine of pi over 3. Well, if it's the same triangle, then the value is the same. Agreed? Because the sides would have the same lengths, which is how we get our cosine. Yes? Now, what is the only thing that's changed by me flipping this over? What's negative? My x and my y are negative in my third. Agreed? So once I flip it, it could change your signs, S-I-G-N, to positive or negative. And so we need to figure out that. In my third quadrant, is cosine positive or is cosine negative? It's negative. So it would have the same triangle, except it would be negative. So we just stick a negative on the front. Agreed? You okay with that? And then we got to think back to what we talked about yesterday. So what angle is equivalent to pi over 3? It is 60 degrees, okay? And remember that we talked about yesterday that cosine of 60 degrees is what? 1/2. And remember my little stuff that we circled here and over here, we said that we just kind of have to have memorized. Okay? So cosine of 60 degrees is 1/2. So then what do I know that this equals? Negative 1/2. We're okay with that? Which was nice because I didn't actually have to like memorize what cosine of 4 pi over 3 is. I only have to memorize what cosine on my first quadrant stuff is. And now this seems like it took a little bit, but the more you do it, you get pretty fast at it. Does that make sense? So it goes a lot quicker. So on my second one, again, what do we probably want to figure out first? What quadrant angle we're in, so that we can figure out what our reference angle is. So this time, what quadrant are we in?
No.
So if I'm going backwards, right, we would be clockwise. So this would be negative 90, negative 180, negative 270. So it would be the third angle going clockwise, which is really our second quadrant overall. Okay? So what do we need to do to find our reference angle first? Add 360. What do we get? Okay? So then what do I do to find my reference angle?
Subtract it from
Yes. And so we get 30. So again, what this tells us is that my tangent of negative 210 degrees is the same thing as my tangent of 30 degrees. Well, what do we need to worry about? The signs. So in my second quadrant, would tangent be positive or negative? So remember, it's A, all. Smart. Sine is positive in my second, so it's negative. Now, did we find tangent of 30 yesterday? For those of us that were here? No, we just found sine and cosine, right? However, okay, once I have this triangle drawn, can I find all of my three functions? Yes, okay. So if I'm looking at 30 degrees, so that's my top angle for this red triangle, what would tangent be? So opposite over adjacent. So 1/2 over square root of 3 over 2. But what was 1/2 for 30 degrees? That was my sine, right? And cosine was the square root of 3 over 2. So what ends up happening is because we allowed our hypotenuse to be 1, right? Remember that my sine ended up being my y value if it's flipped. I'm looking at the top angle, so it's a little bit backwards. And my cosine was the other one. So in general, you don't always have to draw the triangle. If I know what my sine and my cosine are, we can divide those and it will give us our tangent. Does that make sense? So again, it's just kind of one less thing we have to have memorized. I really only need to memorize sine and cosine, and if I know both of those, then I just divide them and it gives me my tangent. Does that make sense? Again, if you're someone that's just really good at memorizing things and you just memorize all of the tangents, that's great. I'm not somebody that's good at just memorizing things. So it's easier for me to only have to memorize my sines and cosines, and then I just divide them anytime that I need a tangent. That kind of make sense? Alright, so we said that our sine is 1/2 and our cosine is square root of 3/2. So let's keep that in mind. So like I said, remember that instead of just memorizing what tangent is, we can say that this is just sine over cosine. Yes? And then like I said, we need to memorize our little bubble. There's not really a way around that. We have to memorize the sine and cosine of everything. So what is sine of 30? 1/2. And what is cosine of 30? Agreed. Do we want to leave it like that? Probably not, okay? So we do have to do a little bit of algebra here. And it is fractions. It's okay. We're all big kids. We can do it. I believe in us. So if I have an improper fraction, what does my big division bar in the middle become? Multiplication. And then what do we do to our bottom fraction? Flip it. So notice what ends up happening to our 2's. They reduce, and we just end up with, okay, but how do we need to rewrite that? Square root of 3 over 3. So that would be our final answer. And again, it took us a little bit, but remember, I'm talking you through every single step, and this is the first time we've done it. So they will not all take this long, I promise. Are we okay with that? Now, on my last one, what did they ask us for? Cosecant. Again, cosecant was not one of the ones we memorized, right? But what did we say cosecant is? It's the opposite of sine. So did we memorize our sines? Or should we be memorizing our sines? Yeah, so we're just going to use that to find cosecant. Again, the fewer things that we have to memorize, the better. We just need to know how to use them. Okay? So for cosecant, what quadrant are we in here? So remember that in my first quadrant, my numerator is 1. In my second quadrant, my numerator is 1 less than my denominator. In my third quadrant, it's 1 more than our denominator. And in our fourth, it's 2 times the bottom minus 1, right? So that would be 8, which is 7. So 7 pi over 4? Is that what that is? No. What's going on there? It's bigger, okay? So what's the ratio between 11 and 4? So is it bigger or smaller than 2? Bigger than 2. And 2 pi is 1 full rotation, right? So we've gone past our fourth quadrant. Does that make sense? Yes? Okay. So what would we do to figure out how far past we've gone? Subtract 2 pi. So 11 pi over 4 minus 2 pi is going to give us what? So 11 pi over 4 minus 8 pi over 4, which is what? 3 pi over 4? So now, what quadrant is that in? That's in our second, right? So technically what happened is we went all the way around and then back to our second. But again, will my triangle look the same? Yeah, because again, I'm going to use my reference angle as my triangle. So it doesn't matter how many times we go around. All of our triangles and reference angles will end up being the same. Yes?
Right.
Okay. So, what would our reference angle here be? What do we get? Pi over 4?
Yes.
So what do we notice about my denominator of the original and my denominator of my reference angle? They're the same. Has anyone caught the pattern yet? They're always going to be the same. It's nice. That's the one nice thing. I know y'all don't like radians yet, but radians are actually a lot easier to find my reference angles because I can look at 4 pi over 3. I know my reference angle is pi over 3 without even having to look at it. Now, 150, I got to think a little bit more because I got to do some math calculations in my head. I don't have to do any math at all to figure out what my reference angles for my radians are. So that's the one nice plus about using radians, okay? So, that tells us that we know that cosecant of 11 pi over 4 has to equal cosecant of pi over 4. But what do we have to check? The sign SIGN, yes? And in our second quadrant, okay, what did we say cosecant is the reciprocal of? Sine, and is sine positive or negative in our second? It's positive. So cosecant will also be positive. Okay? Now again, do we have memorized our cosecant of pi over 4? No. But should we have memorized our sine of pi over 4? Yes, eventually, once we get them all memorized. We should. So that's what we're going to use. So remember we said that this is the reciprocal, right? So if we know what sine is, then we can just flip that. Well, what is pi over 4? Do you remember? Which of my degrees is it equivalent to? 45. So what did we say the sine of 45 is? Square root of 2 over 2. Y'all with me? So then what are we going to do with that to find cosecant? Flip it. So 2 over the square root of 2. And then we need to multiply by our square root. So what ends up happening? We just end up with the square root of 2. Which makes sense because remember, to get square root of 2 over 2, we started with 1 over the square root of 2. So we just flipped 1 over the square root of 2, we end up with just the square root of 2. Are we all okay with that? Yes. We're almost there. So, previously in our notes, we should have had something that looks slightly like this. Right? Remember we drew a circle that had all of our degrees and all of our special radians labeled. Yes? Okay. Now remember, this is our unit circle. So our radius is what? 1. And remember, we said that that's nice because if our radius is 1, what does sine of theta end up being for each of ours? The y value. And what does cosine end up being for each of our values? The x value. So the way that we're going to write that then is next to each of our angles, we're going to write the sine and the cosine with it as an ordered pair. Yes? Agreed? Alright. So, we should know our 30, 45, and 60 because we found those yesterday. What was my cosine of 30 or pi over 6? Cosine of 30 is square root of 3 over 2. So that's going to be my x value. And then what was sine? One half. Okay. Now, what were sine and cosine for 45?
Square 2 over 2.
Okay. And what about 60? My sine and cosine were just flipped, right? From our other one? Are we all with me? Do we all see how I got those three? That's important. We need to figure out those three first, right? Now, the two that we haven't quite talked about are 0 and negative. However, what did we say that our radius is? 1. Agreed? So, if my radius is 1, is my x-axis going to be a radius? From my center to the outside of that circle. Yeah, so what does the length of this segment have to be? 1, and we went to the right, so which one of our variables needs to the right? X or Y? X. So our x value here is going to be 1. Did we move up or down any? No, so what's our y value? 0. So what does that mean cosine of 0 is? 1. And what is sine of 0? 0. Now, when I go up to 90 degrees, again, what's the length of this line segment going to be? Still 1, but 1 in which direction this time? Up. So my x value is going to be 0, and my y value is going to be 1. Y'all with me? So then next, we could keep drawing all of the triangles to find sines and cosines, but we don't really have to. We really have all of our other values. So what did we say our reference angle of 2 pi over 3 is going to be? So 2 pi over 3 has a reference angle of 60 degrees or pi over 3, right? You with me? Like if I found the reference angle of 2 pi over 3, I would get pi over 3. Which means that 2 pi over 3 and pi over 3 have to have the same sine and cosine. Agreed? So that means it's going to have the same point. So if sine and cosine are the same, these values are going to be the same, right? What's the only difference going to be? It's going to be, some of the stuff is going to be negative. So what's going to be negative here? The x value, right? Okay, so that means what does 3 pi over 4 have a reference angle of? 3 pi over 4 has a reference angle of, so what's my denominator? 4. So it has a reference angle of pi over 4. So again, that point that was at pi over 4 has to be the same over here. The only difference is my first one is negative. And then lastly, for pi over 6, what would its coordinates be? Negative square root of 3 over 2, comma 1/2. Are those values just going to keep repeating themselves? All the way around? Yep. You're going to see lots of square roots of 3's over 2's, square roots of 2's over 2's, and 1/2's. So in a second, you're going to break up into your groups, and you're going to fill in the rest of those. Okay? But let's fill in these last two ones that are on our quadrants. So if I'm at 180, again, what is the distance from my origin to the outside? 1. But what direction have we gone this time? Left, which means that which one would be 1? X, and it's going to be what kind of one? Negative. And then lastly, for my 270, what direction have we gone? Down. So that means that my y is going to be -1. Alright? So then I'm going to give you your groups. And you're going to fill in the rest of the unit circle.